so a very great deal of frustration set in through the 70s. However, there's been a really change going on in the last year and the last 6 months, to say the least. And some of that has to do with not only the software and so forth that we're developing and have developing, but also the advent of personal computers and microprocessors. The problem in the area of database management systems in the last 20 years is they've been primarily tailored to the production-oriented applications, the things that people run their businesses with, whether it be inventory control or online order entry systems or what have you, and not geared to the end users. And there have been efforts in database management systems designed to meet those particular requirements, such as inverted file systems and more recently relational database management systems. But if you took all of those systems, inverted file and relational, on the IBM mainframe computer line, there's only about 2,000 of those products installed worldwide, whereas there may be 2 million personal computers now in place. And so the personal computer really reflects, I think, the response to the end user's requirements, much more so than some of the technology we've seen in the software arena. But the combination of the PC and the software on the PC interconnected with the mainframe and so forth, I think, brings to the end user capability that he has been looking for a long time. And I think what I'd like to do now is introduce Bob Goldman, who's the president of Cullinet Software, to continue with the presentation relative to some of the problems and opportunities associated with PCs and also with mainframe and integration. So Bob, you want to pick it up from here?
Thank you, John. I have some slides. I guess we're going to get the lights dimmed here. And I put together a fairly brief presentation to give you a sense of what problem, what dilemma that we're trying to solve with this integration of the mainframes and personal computer software. And let's see if this... The basic question is, we have a very powerful personal computer. We've a lot of strides have been taken in the last 4 or 5 years to put together a very elegant system from a personal computer standpoint. There's been a lot of work done on the mainframe, companies such as ours and others that have put together very elegant software on the mainframe. But the major problem that has not really been addressed is getting the information from the mainframe into the personal computer and then getting it back. Example of the problems that have been brought up is at Cullinet, we have a couple of IBM PCs that are used by the financial planners, and we have a corporate general ledger system that we're running the GL. One of the things that we wanted to do was to produce a new budget on the personal computer, basically using variable budgeting techniques from the information in the existing budget in the GL system. Well, as you can imagine, what had to happen was a report had to be produced from the mainframe. The information from that system then had to be typed in to a spreadsheet system on the IBM PC. All of the budgeting and projections were done on the PC, and once the budget was derived for next year, then what we wanted to do was put that budget information back into the mainframe so we could run some actual to budget comparisons. So we had to get the information out of the PC, type it back into the mainframe system to update the corporate GL. And this is typically what has been happening for people that are trying to use the personal computers in connection with the mainframe, because that elegant interconnect really isn't available. What I'd like to do at this point is kind of look a little bit at some of the history as to why we got to this point. Looking at the hardware end of it, we've had some major integrated solutions, companies that you're all familiar with, Apple, IBM, Radio Shack, and others, that have put together the CPUs, the color and black and white monitors, the floppy disk, the hard disk, the keyboards, modems, the printers, all of these pieces that have been integrated together to be a complete hardware solution. And you'd all expect it to work that way. You'd be very surprised if you had to buy a keyboard from one company and buy a monitor from another company and buy a CPU from somewhere else. You may choose to do some of this in a plug-compatible form, but if you absolutely were forced to do that, it would be a very difficult, time-consuming effort to end up with the hardware that you want. Well, on the software side, that's really where we started out. What we had was no integrated solutions whatsoever. We had some initial spreadsheet systems that came out, other functions that were added, but typically what happened is if you want to switch from a spreadsheet to a graphics system, you had to take the one floppy out of the system and load another floppy in, and it became very cumbersome to get between one package and another. So what happened with the second generation in the area of software was the integration of some of these products. And we started to see some of the pieces being put together, like the spreadsheet and graphics or database, but still not really integrating the complete solution. The third generation, if I can use that, it's interesting because the mainframe world took 25 years to get to the third generation, and the PC, by this definition, took about 4. So it gives some example of the speed at which this is moving. But the third generation is really integrating all of these kinds of software together into being a complete set of productivity tools that are working together. And some examples of this, the software products that we're building for the IBM PC, and clearly what has been done on the Lisa system from the software standpoint there. On the mainframe, we have the complete software integration product. Over the years, companies such as ours have put together a software solution of integrating the 3 major areas, which include database management. The function of database is basically to do 2 things: to store and retrieve data in a secondary file, to relate data to each other, to relate a customer to his orders, to relate an employee to the departments they work in, and then surrounding the DBMS a set of tools through which the applications people build application systems or application development tools. The next area, and integrated on that, was in the area of application software. Basically, application software are things like general ledger systems, account payable systems, order entry systems. And the integration of the applications is really in 2 modes. One is what we call vertical integration. By that I mean that these applications are built using the database technology and built on the tools that are available from a DBMS standpoint. The second kind of integration is what we call a horizontal integration. Horizontal integration basically meaning that all the different applications work together. Purchasing shares vendor information with accounts payable, and so on. So the idea of integrating these applications was the next step. And then finally, the third step, which was to integrate the decision support tools, which are basically the products that allow management to get information out of the computer system by themselves. Now, the integration of the decision support systems with the applications, with the database, means that for the first time, you can act on current data that exists in the corporate database that was generated by the current applications. So these kinds of integrated mainframe solutions have been available for some time. What we're seeing now is the beginning of having integrated personal computer solutions. The problem that exists today, though, is now to interconnect those 2 kinds of capabilities. Interconnect the PC integrated solution to the mainframe integrated solution. Now, if we look a little bit at the history of the interconnect between PCs and mainframe, the first thing that we see is the hardware connect. Basically, a hardware connection between a PC and a mainframe is put a modem on a PC, have a telephone line, dial it up, have teletype software or terminal emulation software residing in the PC, and now you've connected to the mainframe. Well, it really doesn't solve the problem, because in order for that to be valuable, the user at the PC needs to know everything about the mainframe languages and the mainframe systems in order to get any data. So this kind of solution, while it does allow a personal computer to be interconnected to a mainframe, is not easy to use, and certainly not end-user oriented, the kind of thing that anybody can sit down and get into a mainframe and then be able to get the kind of information they want. The second type of interconnect is what I call a limited software connection. What I mean by this is that this connection is specific to a given application on the mainframe. And what's happened is for a given application, whether it's general ledger or inventory or order entry, some specific software has been developed to allow those particular files out of the general ledger system to then be downloaded and made available to software on a PC. This is a much easier solution on the personal computers. It's a much easier solution for the PC users, but it's not a generalized solution. If in a company you have many different applications on the mainframe, which of course exist, then you end up with a different solution for your general ledger, another solution for your inventory system, another solution for your order entry system, and potentially there's a sales tracking system, and that has yet another solution. So you end up with all these different techniques, and any given user, depending on the kind of data that he wants to get from the mainframe, has to know which one of those links to use and how to talk with each one of those links in order to get the data that he wants. So this kind of solution, while it's easier, is still very limited. What we see as a complete solution is what we call an information database. The information database resides on the mainframe and basically contains summary level information from all the different sources of data resident in that mainframe environment. Some of that data might come from the production database system, and we're talking about general ledgers and inventories and order entries. Some of the data may come from non-database systems, non-database files, or maybe other kind of file systems that reside in the mainframe environment. And still other kinds of data may come from data outside of data processing. This is information that's been purchased by the organization. It may be information from Chase Econometrics, it may be information from DRI, it may be other types of research or sales research data that's available. And all of these things are then brought together, summarized, and then maintained within the information database. The information database really solves two major objectives. The first is as a mechanism or a depository to collect all of the information within the corporate environment from wherever the source is. The second is it's the extension to the PC. It's the intelligent software on the mainframe that can then talk to the personal computer and handle the inter-computer communications to get the necessary data sent back and forth and to allow people to connect to a mainframe without having to know a lot about detailed data or detailed information. So in effect what it is the universal link from the mainframe to the PC environment for any kind of personal computer and for any type of data that's resident in the mainframe. If we look at the different uses of an information database environment, the first one is the ability to download data, and I think this is the most common use when people talk about interconnecting PCs to mainframes, is to get information from the mainframe downloaded to the PC. The intent here is that the personal computer can sign on to or connect to the information database, and then in effect, without knowing any languages, any mainframe languages, not having to know how to speak the various mainframe languages, can see what's available in the information database and in effect walk through the various kinds of files. And you can think of folders with files within it, and a user can walk through those files and those folders to look at the kinds of information that's resident in the mainframe, and once he sees what he's interested in, then just pointing that one out and then having the software take care of physically downloading that software to the PC environment. So this type of link allows that universal communication to get the information from the mainframe downloaded to the PC. The next type of objective is what I call a mainframe storage capability, but it's really a lot more than that. It's the ability to go the other direction. It's certainly necessary to be able to download information from the mainframe to the PC, but we also find it's very necessary to be able to put information from the PC back to the mainframe. The example that I talked about earlier of the general ledger system and wanting to create the new budget and then using that to update the mainframe system says in effect that I've got to have the ability to go the other direction and create files on the PC, put them back on the mainframe. Well, once I've got that ability, I can really use it for a couple of facilities. One is I can use it for an extended storage facility in the PC. If you get into some of the PCs with just the floppies, there's a limited storage capability. So with this kind of mechanism, I can now use the mainframe as an extended storage facility for my PC. And I can just put information up there and not have to worry about keeping track of it in the PC environment. PC users can create information on the PCs and then be able to store it back on the mainframe. It's also a facility to allow PC users to create information that goes into the mainframe, which will subsequently update the production database. One thing that we don't want to allow to happen is for personal computer users to have random ability to update the mainframe production systems. Because of course we're creating our checks and putting out the orders, all the things that are happening in the mainframe. We want to be very cautious about what updates the mainframe system. We've written a lot of programs in data processing to basically do all the edits and the validations and the security checking before we end up updating the production system. So if we're not going to allow the PCs to update the production system directly, what we can use the information database is for a buffer between the PC user and the production database, so the PC user can put information back to the information database. That then can serve as input to update the production system. And through that mechanism, we can maintain the security and the validation that is necessary in the production database systems. The third major objective is to use the information database as the networking device, or in effect to use the mainframe as a networking device to network the personal computers together. This type of capability, and you can see how somebody could create something on a PC, put it away in the mainframe, in the information database, and then another user can then access that file and download it to his own PC. So the whole question of electronic mail can be solved by using the mainframe as that conduit for passing the information back and forth. And the other thing that this solves is the whole question of networking and looking into the whole area of local area networks and new networks that have been required and trying to tie the PCs together through Ethernet kind of capabilities. In, again, large organizations, there already is a complete communications network that's been built up connecting all the terminals to the mainframe. Now, there's no reason not to take advantage of that type of network in this environment to allow all the PCs to communicate through that network. And that could be done through the whole concept of the information database. So this whole solution is really bringing, we call the desktop to the database, but it's really bringing together from the PCs on the desktop to the microcomputers and solving that intelligent link between the mainframe and the PCs so that we can solve this problem of how do I get the corporate production information downloaded into my PC in a way that I want to look at it and without having to learn all the mainframe languages. Once I get it downloaded, is there any way that I can get it back in the mainframe? And that's whole concept is through the information database. So that's basically a presentation, just to give you a sense of what we've put together in this link and this concept of an information database. And at this point, I'd be happy to answer any questions that anybody has. Yeah.
Could you tell me what the transfer rate is and baud rate of this communication?
The question is, what is the transfer rate and baud rate of the communications? And I assume you're meaning between the PC and the mainframe. Obviously, it's going to vary depending on the hardware connection that exists, but typically it would be a 9600 baud connection if it's a remote terminal. And if it's a local terminal, obviously it channel rates within the mainframe.
Could you describe the specific Cullinet products that are available or that will be available?
The specific Cullinet products that are available, traditionally, our area has been in the mainframe side of it. And the areas in the mainframe have been the database management system, IDMS is the product, and various other tools that work with IDMS to create an environment for developing applications. Application software itself, things like the manufacturing systems, general ledger systems that are integrated with the database products, and decision support systems, graphics, to allow top management to get that information the way they understand it. Now, what we've expanded that to is the interconnect of that software on the mainframe to the personal computer. That's through two primary areas. One is the information database, which is a product that will run the IBM mainframe. And that product will be integrated with the database products such that the information from the production database can automatically update the information in the information database and provide the necessary summarized data to be available to the PCs. On the personal computer side, there is a complete integrated set of software products on the PC, it's going to be running the IBM PC, that includes spreadsheet analysis, includes graphics, relational database capability, word processing, and then of course electronic mail through the mainframe and the interconnect back to the mainframe. Now the product that we are building on the PC, is for the IBM PC. In addition though, we've seen a requirement for Apple Lisa systems to also connect into the mainframe environment. So we have put together a joint agreement with Apple Computer such that the Lisa system will be able to interconnect to the information database on the mainframe.
Since neither of those products conform to the IEEE specs, either 686 or 696, do you have plans to support computers that do, PCs that do?
Right now, the plans are primarily in the IBM PC and the Lisa area. We have looked at and will continue to look at other systems, but the major area, as you can see, that we're addressing is the interconnect between the mainframe and the large, traditionally IBM mainframe environment to the desktop computers. And most of the buyers, the market of that environment, are the IBM PCs and the Lisa systems.
Interconnect to the Lisa, will you be using AppleNet?
In the connect to Lisa, we'll be using AppleNet. The answer is no. We'll use the same 3270 type of connection, emulating 3270 terminal back to the mainframe.
In regards to the application software on the right side of the link, the right side from where we see it, the PC part of that software, are you getting involved in the application software as well?
Are we getting involved in the application software on a personal computer? At this time, no. Basically, the products, again, are the productivity tools on the PC to be interconnected to the applications running in the mainframe.
And one can assume that the productivity tools will be integrated.
Absolutely. Yes, they'll be integrated in the sense of a 1, 2, 3, that type of integration.
One last question. When can we expect to see the application, the productivity tools for the PC entering the market?
December.
How will you handle async, bisync, and SDLC?
How will we handle async, bisync, and SDLC? SDLC and bisync will basically be handled just as a 3270 and standard 3270 access methods, whether it's VCAM or
Would you go through coax to an IRMA board, or
most likely, yes.
how about the IBM sync board?
Right now, we're primarily looking at the IRMA board. The major difference being the IBM 3270 emulator package doesn't give you any exits to be able to track the data stream coming in, which we need to do, obviously, in its sort of way locally.
Finally, will there be any opportunity to handle that through software through async?
Will there be an opportunity to handle the software through async? Yes. what's missing even on the board is in all these async capabilities, there's no error check or correction protection, and that's, we've got to build all these, so.
Is your pricing established?
For
Pricing.
pricing, we initially will be pricing the PC software for $1,000 per copy. The information database residing in mainframe will be $75,000.
Will it be possible to use the PC software without the information database?
Will it be possible to use PC software without the information database? Yes. Certainly we'll run through all those functions on a standalone basis. But initially, as you saw in the complete software solution, database applications, decision support, PCs, the information database, are intended to market it as a complete solution. The mainframe end markets.
One last question. Will the software on the PC have any kind of application development capability in itself?
Will the software on the PC have any application development capabilities by itself? Yes, in a sense. The relational database capability does have the ability to build applications in the sense that you can define a template of a record and then create a screen for that record and be able to put that information in and edit it and store it away and then get reports and ask questions about it. It doesn't have or will not initially have a programming interface to BASIC and Pascal and other languages, but the kind of applications that can be done inside itself, yes.
When will you be releasing more technical specifications about the product?
Probably sometime this summer.
IDMS itself, I believe, is a network database, and you talk about a relational database. Is this another product, sort of like a one of these, like DBase 2 or something else, some different software product that's relational? I'm a little confused by the word relational with respect to IDMS.
Well, IDMS traditionally has been a network system on an IBM mainframe. We announced a few weeks ago, about a month ago, IDMS R, which is a relational database system for the IBM mainframe. And it is really a growth, or really a new product with relational capabilities that runs in conjunction with the network capabilities that have already been in existence. And what we found is that in an IBM mainframe environment, there's two different requirements for processing. One is the production orientation, production applications. And these are the systems that are really the bet your business kind of applications. Your order entry, general ledger, inventory control, the types of things that have to be up and running here or the company's out of business. They need the high performance and the recovery and all the aspects that a network system provides. And that's what IBM has traditionally done very well. There's another requirement, which is, I call end-user applications. These are simpler applications in the sense that they can be put together by somebody. Typically, they only have a couple of users, and they're not really used for those major corporate venture business activities. That kind of application is very well suited to relational technology. So what IDMSR is, it's a combination of both of those production capabilities in the network model and the ease of use on the relational side, so that once somebody gets into IDMS, if you will, they have a choice. They can do things the network way they always have for the production orientation and the high volume and transaction orientation. Or they can use it as a relational system to build their single one-of-a-kind systems. Now, through that, they have the ability to move back and forth between the network and the relational model. If somebody chose to do everything relationally, they could, or if somebody chose to do everything in a network way, they could, or they can share information back and forth. On the PC, I don't see, at least in the use that we've defined initially, the product will not be used for large production applications. It's a single user, single terminal system, and people will basically use it to either develop their own private applications and keep track of their information. Therefore, that defines an end-user application, which says that relational technology makes the most sense in that environment. So what I see on the PC, or what we're doing in the PC, is building that relational model. And naturally, the relational model on the PC will be, from a user interface interface standpoint, the same as the relational model on the mainframe as that part of IDMSR.
Will the software be entirely resident on disk, or will it involve any kind of board or card or whatever?
The software will be entirely on disk. The part that would be on the board would be something like the Irma board or 3070 Interconnect.
And you have no plans for releasing compatible versions for other MS-DOS machines, such as the DEC Rainbow?
We have no plans for releasing it for other MS-DOS machines. Certainly compatible machines, I'm talking about the 8080 series and MS-DOS, would certainly run in that environment, since that's what we're pulling at PC. Initially, no, but I think a lot of that is driven by the marketplace and the requirements of it.
At the present time in the LISA, the only thing that's available is a very simplified list management system. When you talk about a relational model for the PC, does that mean for the LISA as well, or are you talking about the IBM PC?
The question is, the database capability in the LISA right now is kind of a simplified list capability. And what we're talking about of a database on the PC, we're talking about just the IBM PC or both LISA and IBM PC. The answer to that is what we're implementing is software strictly for the IBM PC. What we are doing with Apple is working with them to interconnect LISA to the information database. And the concept is, if you're familiar with the LISA system, is there will be a new icon on the screen which will say Cullinet Information Database. By invoking that particular icon, what you will then see, the system will make a connect to the mainframe if one has not already been established. Once the connect to the mainframe is there, the user will see a catalog of all of the files and folders that are available for that user on the mainframe, and using the mouse you can then walk through those to come to a point to say, this is the one I want. And at that point, that file will be downloaded and stored locally on the LISA system.
How does IDMS-R allow you to access databases other than IDMS?
How does IDMS-R allow you to access databases other than IDMS? It's really not so much a question of IDMS-R accessing databases other than IDMS. It's the information database. Being able to collect information from other than IDMS-R databases. Because what you've got is a production database, which is IDMS, and there's going to be the production files in there. Now, some of what's in the information database will be just a mapping into what exists in the IDMS database. In other cases, what will be in the information database is the physical data itself. Now, that physical data may come from outside tapes. It may come from other kinds of non-database files. It may come from a lot of different areas.
Could you access an IMS database?
Yes.
How is that done?
That will be done through building the data in the information database from an extract of the IMS database. And typically what you see is in a production database is characterized by having a lot of detail for a very short time frame. If you look at an order entry system, they have, for every order that's entered into the system, 2,000 characters of information about due dates and ship dates and addresses and ship addresses and so on. And typically has that information for a very short time frame, 30 days, 60 days, 90 days, whatever the time period is. So a production database has that characteristic of being very detail-oriented, very short time frame. Now, if you look at information and what managers want as information out of the database, what they're looking for is something that is much more summarized information over a very long time frame. I may be interested in how many IBMSs did we sell in the Northeast in 1982. Now, that type of information wouldn't be maintained typically in the production database. One, because I couldn't keep all the orders for a whole year because there's too much data for each one. So what I want to do is separate the requirements of the production database, which is IBMS or IMS, and then define the requirements of the information database, which is a much more summarized level of data over a long period of time, put that into the information database.
Does the system programmer have to do that?
Does the system programmer have to do it? No. It could be done, there are utilities to define the information and, in effect, read the information out of my IMS database and update the information database.
So to summarize, you have utilities that will allow you to access any type of database there is out there.
That's right. And non-database files as well.
Fantastic.
Can a customer buy the information database and not buy IDMS?
Yes.
Yes, what will be the size of the PC application? Will it reside on floppy or will you need a hard disk?
Will the PC system reside on floppy or will it be on hard disk? Since it's not all complete at this point, it's kind of already answered, but the design goal is to have it all reside on floppy and not require a hard disk.
Could you describe the structure of the information database?
Describe the structure of the information database. The structure will basically be like a relational DBMS. It's going to be flat files, tables of information, but there are many different types of information that can be maintained in there. One sense would be a well-defined table, and you can think of sales by district, and that's well-defined with rows and columns and the information in each one. But you may also have non-structured information in the information database. You could think of running a report off of the mainframe system, and instead of physically printing the report, put the output of the report into the information database in exactly the report format. Then the PC user can sign into the information database and see that the new report has been generated, download it to the PC, and then manipulate it. So it doesn't necessarily have to be structured relational data. But for the files that are structured in third normal form and rows and columns and so on, then the opportunity to use the relational operators on will be there.
How much core on the PC?
How much core in the PC? The design goal, again, we don't have the final numbers, but the design goal is to be probably 120K.
How do you plan on controlling the unauthorized distribution of the PC program?
How do we plan to prevent the unauthorized distribution of the PC program? That's a great question. Does anybody out there can answer it? I think certainly our goal up front is to sell primarily into corporations and not be selling, selling a complete integrated product line. And in that sense, connecting it to the information database, and there's ways that we can do some things to protect it. But I think, there's a lot of techniques that are used out there, and we certainly don't know what they all are to prevent the duplication of these things.
Following up then, do you intend to have variable pricing for corporations based on the quantity of terminals?
We intend to have variable pricing with corporations based on the quantity. We announced this product April 19th, and on April 29th, we got a call from a company who wanted to know, our sales rep was out there signing a contract, and they wanted to know what our price would be for 3,000 copies. If there was a price break, so we came up with one. So yes, the answer is certainly will. We have time for 2 more questions.
If I understand what you're saying, your market is 2,000 installed database system users, which to me, just simple arithmetic, 2,000 users times $75,000 per hit would give something like 150 million. Considering that installed micros go anywhere between 2 million up to 50 million in the next few years, multiplying 50 million times 1,000, to me, I don't understand how you're only marketing the big stuff.
The basic premise is that we're selling this to 2,000 customers. There are somewhere in the area of 50 to 60,000 IBM mainframes installed throughout the world. That is the market for that $75,000 product. And I think if you multiply that out,
well, considering if it were a standalone integrated system for the micros. 50 million possible sales. It's not something to shy away from.
Oh, absolutely not. I would certainly agree with that. And I think, if somebody wanted to buy it from us, I don't think we'd send them away. But on the other hand, the initial market, if you really look at it, the whole area of selling single copy systems is really a different market than we have traditionally been in.
Well, do you want to get into a $2 billion market?
We want to get sure. Yes, the answer is yes. I think you dropped it there. No, but it's a question of timing and initial thrust.
Given the size of your program, it sounds like you're going to have some rudimentary programs within it. For example, the word processor will probably not be even a WordStar quality, I would guess. And it sounds like you're not going to have a real sexy user interface like the people we know and love. Is that true?
No.
What are you going to have?
Well, that's it, Bob.
Two questions. There's, no, I think the best thing, I don't know if you've seen a product, TrendSpotter, which is a computer pictures system that we acquired the company, and of course the product with it. But one of the major thrusts in TrendSpotter was user interface, and a very simple user interface, basically touching a button and getting a graph up. So there is a lot of expertise in that area, and I think we're very, very conscious, especially coming from the mainframe side, how important a very simple user interface is. And we are, just very knowledgeable. We're certainly aware that we have to be very careful and produce something that is very, very simple to use and does integrate these functions. And I think the other part of your statement, the product's not necessarily being the quality, is not necessarily true as well. We have looked at and have acquired some tools which will help us in the implementation of these systems. And through the acquisition of some of these tools, we are getting, in effect, very sophisticated systems. I think that's all the time again. Thank you very much.